Hey everyone, welcome to Math 104. We're working on section 8.2 today, the quadratic formula. So here's the quadratic formula. Maybe familiar to you. Negative b plus or minus square root of b squared minus 4ac over 2a. So you've got this interesting symbol here, plus or minus. And this means we can either be adding or subtracting. So we actually have two equations wrapped up in this one equation. We've got the positive version, which uses addition here, and we've got the negative version, which has subtraction there. So we're generally going to get two answers out of these types of equations. Now, you can tell a quadratic equation because it has a highest exponent of 2. Here's a quadratic equation in standard form, and that's going to be the first step when we're using the quadratic formula to solve a quadratic equation. We're going to write that equation in standard form first. And the reason is, it'll be easy to pick out the values of a, b, and c. And that's step 2. Then we're going to take those values of a, b, and c and plug them into the quadratic formula and evaluate. So let's take a look at this in action. First example here, it's already in standard form, so we need to pick out the values of a, b, and c. Now, a is the coefficient on the x squared term, so that's a 3. B is the coefficient on the x term, that's a negative 3. Always keep the sign with it. And c is the constant, so that's a negative 6. Now we can plug these into the quadratic formula and solve. And we've got, in the quadratic formula, it's negative b, so it's going to be negative of whatever b is. Here b is negative, so I'm going to put that in parentheses. Plus or minus. Now we got b squared, so that's negative 3 squared. Minus 4 times a, which is 3, times c, which is negative 6, all over 2a, which is 2 times 3. Now we've got some simplifying to do. So negative of negative 3 is positive 3. Negative 3 squared is 9, minus 4 times 3 times 6. 4 times 3 is 12. Times 6 is 72. But we got a negative there, so it is negative 72. So this is where we have to be real careful. We're subtracting here, bring that subtraction sign down, and then whatever you get from multiplication, if it's negative, put it in parentheses. And bottom, 2 times 3 is 6. So that gives us 3, plus or minus. And underneath here, subtracting the negative turns into addition. So that is square root of 9 plus 72, all over 6. And 9 times 72 gives us 81. So we have the square root of 81, that'll be 9. So we got 3 plus or minus 9 over 6. And now at this point, since we have some whole numbers up here, we can actually evaluate these. So this turns into two separate equations. So x is 3 plus 9 over 6, and 3 minus 9 over 6. Evaluating these, we got 12. So we got 12 over 6, and here 3 minus 9 is negative 6, so negative 6 over 6. And so that makes our two values 2 and negative 1. And as always, we get our answers. We should plug them back in the original equation to see if they work. And in this case they do. So we're going to work on your turn number 1. Let's solve 2x squared plus 2x minus 12 equals 0 using the quadratic formula. So we're already in standard form. Let's go right to picking out A, B, and C. All right, on the x squared term, we got a 2, so there's A. The x term is a 2, so there's B. And the constant is 12, or negative 12, so C equals negative 12. All right, let's plug them in. X equals negative of B, so that's negative 2, plus or minus square root B squared, so that's 2 squared, minus 4, times A, which is 2, times C, which is negative 12. All over 2 times A, or 2 times 2. So now we're going to simplify underneath this radical here. 2 squared is 4. Here we got, 4 times 12, or negative 12 is negative 48, times 2 is negative 96. So we're subtracting negative 96. All over 4. So now we've got negative 2 plus or minus. This turns into addition, so that's 4 plus 96, all over 4. And so x equals negative 2 plus or minus the square root of 100, all over 4. All right, square root of 100 is 10, so we got negative 2 plus or minus 10 on top, all over 4. All right, now let's see what we got. That's going to be negative 2 plus 10 over 4, and negative 2 minus 10 over 4. So x is going to equal 8 over 4, or negative 12 over 4. So that means x equals 2, or negative 3. All right, now some quadratic equations are going to produce one distinct solution. And we'll see that that is actually 2 matching solutions. So let's look at 4x squared plus 9 equals negative 12x. Now, for the first time, we actually see one here that is not in standard form to begin with. So our first step is going to be to put it into standard form. So what I'm going to do is add 12x to both sides. That's going to bring it over to the left, giving us 4x squared plus 12x plus 9 equals 0. Now let's pick out the values of A, B, and C. We've got 4 here for A, 12 here for B, and 9 for C. Now we can plug them into the quadratic formula. It's x equals negative b, it's negative 12, plus or minus the square root, b squared. That's 12 squared minus 4 times a, which is 4, times c, which is 9. All over 2 times a, or 2 times 4. Next up, we're going to simplify underneath the radicals. So we have negative 12 plus or minus the square root of 12 squared is 144 minus 4 times 9 is 36 times 4 is 144. So we got 144 minus 144 over 8. So this is going to be 0 here. The square root of 0 is 0. So that goes away. So that reduces down to negative 12 over 8. We could reduce this fraction. And we get negative 3 halves. We just get one solution. So why does that happen? Well, the reason it happened using the quadratic formula is because we got 0 here. And the 2 solutions come from the fact that we're adding something to get one solution, and we're subtracting that thing to get a different solution. But if it's 0, it doesn't affect the negative 12. So we don't get 2 solutions out of it. We just get the one solution. Now let's look back at some of the other techniques we've used to solve these. If you recognize this as a perfect square trinomial, that factors into 2x plus 3 times 2x plus 3. So 2x plus 3 squared equals 0. So to solve this, we're going to set 2x plus 3 equals 0. be a negative 3/2. So like we saw before when we were solving perfect square trinomials, we only get one solution there. And when we use the quadratic formula, we get one solution that way as well. That brings us to your turn, number 2, x squared minus 6x plus 9. Alright, so we're starting off in standard form. We have no coefficient here, so let's assume to be 1. B is negative 6. And C is 9. So negative B will have negative of negative 6 plus or minus square root negative 6 squared minus 4 times A, which is 1, times C, which is 9. All over 2 times 1. Alright, negative and negative is positive, so we got positive 6 here. Plus or minus, negative 6 squared is 36. Minus 4 times 1 times 9 is 36. So it'll also give us a 0 underneath the radical. So this turns into 0, that goes away, so we got 6 over 2, which is 3. So we got a single solution to that one, or 2 matching solutions at 3. So what we've seen up till now is all rational solutions. Now let's look at some that have irrational solutions. For example, 2x squared plus 19 equals 14x. So this is not in the standard form, so the first step, we're going to put it in the standard form by subtracting 14x from both sides. That'll bring it over to the left, giving us 2x squared minus 14x plus 19 equals 0. So let's pick out our A, B, and C values. A is 2, B is negative 14, and C is 19. Plug them in. Negative B, B is negative 14. So negative of negative 14 plus or minus B squared, so that's negative 14 squared minus 4 times A, which is 2, times C, which is 19, all over 2A, or 2 times 2. So simplifying, negative and negative is positive, so we get positive 14 there, plus or minus square root of, see, 14 squared was at 196. Yeah, 196. And then we got 4 times 2 times 19. That is 152. So underneath radical, we got 196 minus 152, all over 4. So simplifying underneath radical, 96, 52, that gives us 44. All over 4. Now, if this radical cannot be simplified, and we can't simplify here, we would be done. But we can do some simplifying here. So we can break up 44 into 4 times 11, and that gives us the square root of the perfect square. So we got 14 here, plus or minus the square root of 4 times the square root of 11 all over 4. Now this reduces to 2 square roots of 11 over 4. And now we can factor out a 2 from up top. That gives us 2 times 7, plus or minus. Keep that plus or minus, don't lose. See a lot of students at some step they're going to lose one of those signs or something like that. Keep that plus or minus. Gives us 7 plus or minus the square root of 11. And the bottom can be factored into 2 times 2. Now we got 2's to cancel. Now this cannot be simplified any further than this. So we got 7 plus or minus the square root of 11 over 2. Now we could write this as 2 solutions, 7 plus the square root of 11 over 2 and 7 minus the square root of 11 over 2. But those two are contained in that one expression. Next up, your turn, number 3. 9x squared plus 6x equals 1. So we're going to put this thing in standard form. Let's subtract 1 from each side. 9x squared plus 6x minus 1 equals 0. So we've got a is 9, b is 6, and c is negative 1. Alright, so we've got negative b, so that's a negative 6, plus or minus the square root of b squared, so that's 6 squared, minus 4 times a, which is 9, times c, which is negative 1. All over 2 times a, or 2 times 9. Alright, negative 6 plus or minus square root of 36 minus negative 36. All over 18. Combining those, you're going to add 36 and 36 to get 72. And now we can break up 72 and simplify it. So 72 breaks up into 36 times 2, and 36 is a perfect square. So we got negative 6 plus or minus the square root of 36 times the square root of 2 all over 18. And this turns into 6 square roots of 2 all over 18. Now we should look for opportunities to simplify. So up top we can factor out a 6 to get negative 1 plus or minus the square root of 2 all over, and 18 breaks up into 6 times 3. Alright, now the 6's cancel, and that gives us x equals negative 1 plus or minus the square root of 2 all over 3. So all the solutions we've seen so far have been real numbers. They've been some rational, some irrational, but all of them are real. We've had no complex or imaginary numbers. But complex numbers were created for a reason, and this is one of those reasons. Now let's take a look at x squared minus 4x plus 5 equals 0. So that gives, we're in standard form, so go right to step 2. A is 1, b is negative 4, and c equals 5. Let's plug it into the quadratic formula. So we got negative 4 here, so negative of negative 4 for b, plus or minus b squared, which is negative 4 squared, minus 4 times a, which is 1, times c, which is 5. And that's all over 2 times a, or 2 times 1. Simplifying, negative times negative, that gives us positive. Here, plus or minus, square root of 16, minus 4 times 1 times 5 is 20. 16 minus 20 over there, all over 2. So we get the square root of negative 4. This is the first time we've seen a negative number underneath that radical. And when we take the square roots of negatives, we're going to get imaginary numbers. So let's break this thing up. That gives us 4 plus or minus I. Alright, we're going to change square root of negative 4 into I times the square root of 4. And now, square root of 4 is 2, so we get 4 plus or minus 2i over 2. You can factor 2 out of the numerator, and that gives us 2 plus or minus I over 2. Canceling the 2's, we get 2 plus or minus I. So 2 plus I or 2 minus I. And those are our two complex solutions. That brings us to your turn, number 4. X squared plus 2x plus 5 equals 0. We're in standard form, so go right to step 2. Gives us a equals 1, b equals 2, c equals 5. Now let's plug it in, see what we get. Right, negative b, so that's negative 2, plus or minus square root 2 squared minus 4 times 1 times 5, all over 2 times a over 2 times 1. Now we got 4 minus 20 underneath the radical, all over 2. Gives us negative square root of negative 16. So we'll turn that into I times the square root of 16, all over 2. Square root of 16 is 4. So we get negative 2 plus or minus 4i over 2. Now we can factor 2 out of the numerator. So x equals 2 times negative 1 plus 2i, all over, plus or minus, negative 1 plus or minus 2i, all over 2. And now our 2's cancel, and we get x equals negative 1 plus or minus 2i. So we've seen some have solutions with complex numbers, and some have solutions with irrational numbers. But some of them have solutions that are a mix of both of them. So that's what we're going to look at next. x times 3x plus 4 equals negative 2. May not even be immediately clear that this is a quadratic equation. But if we expand here, right, I'm going to clear these parentheses by distributing the x in. So that's 3x squared plus 4x equals negative 2. Then we can move the negative 2 to the left, making it positive. So that's 3x squared plus 4x plus 2 equals 0. Now we're in standard form. So we can pick out the values of a, b, and c. A is 3, b is 4, c is 2. Now plug it into the quadratic formula. Negative b, that's negative 4, plus or minus square root of b squared, or 4 squared, minus 4ac. 4 times 3 times 2, all over 2a, which is 2 times 3. 4 squared is 16. 4 times 3 times 2 is 24. And all over 6. That gives us negative 4 plus or minus square root of negative 8. All over 6. All right, now we got a square root of negative value, so we're going to turn that into negative 4 plus or minus I times the square root of 8. Now, square root of 8, we can simplify that and break that up into square root of 4 times the square root of 2. All over 6. Square root of 4 is 2, so we got 2i square root of 2 over 6. Now we can factor out a 2 up top. 2 times negative 2 plus or minus I square root of 2 over 6 is 2 times 3. Now we can cancel those 2's. So that gives us negative 2 plus or minus I square root of 2 over 3. And now to express our answer in standard form, complex numbers, it's traditional to split this up into negative 2/3. All right, here's one side of the fraction. Here's the real part of the fraction. Plus or minus. And the imaginary part goes over here, so I times the square root of 2 over 3. And there's the equation in the standard form for a complex number. All right, that brings us to your term number 5. X times 2x plus 3 equals negative 2. All right, distributing it, we got 2x squared plus 3x equals negative 2. Now we can bring the negative 2 to the left, turn it positive. 2x squared plus 3x plus 2 equals 0. So that gives us a equals 2, b equals 3, and c equals 2. Plug it into the quadratic formula. Negative b, so that's negative 3, plus or minus square root b squared, that is 3 squared, minus 4 times 2 times 2, all over 2 times 2. All right, next up, let's simplify underneath the radical. Negative 3 plus or minus square root of 9 minus 4 times 2 times 2 is 16, all over 4. Right, 9 minus 16 is negative 7. So that gives us negative 3 plus or minus square root of negative 7 over 4. Now we can write the square root of negative 7 as I square root of 7. So that gives us x equals negative 3 plus or minus I square root of 7 over 4. Now putting it in standard form, all right, we can't simplify this anymore, so we just write it as negative 3/4 plus or minus I squared root of 7. Actually, a lot of people usually write it as the number and then the I. So we'll do square root of 7 over 4I. So that's more common to write it that way. So we've seen examples of several different types of solutions. We got 2 real solutions, 1 real solution, and 2 complex solutions. And we can determine, without actually calculating the solutions, what type we're going to have. And we can do that by finding a value that is called the discriminant. And the discriminant is that value lies underneath the radical in the quadratic formula. B squared minus 4AC. And the value of that is going to tell us what types of solutions we have. So take a look at the table. Number of solutions based on the value of the discriminant. If the discriminant is greater than 0, we have 2 real solutions. If the discriminant is equal to 0, we have 1 real solution. If it's less than 0, we have 2 complex solutions. Alright, so let's see why this is the case. Now let's say that b squared minus 4ac is greater than 0. That means we have a radical here of a number greater than 0. If we take the square root of a number greater than 0, we're going to get some type of a real number. So only when we take square roots of numbers less than 0 do we get complex numbers. So we get an actual value here that's non-zero, it's positive, and we add or subtract that positive value. When we add, we get 1 solution, when we subtract, we get the other solution. So there's 2 real solutions. Now, second situation, discriminant is 0, we get 1 real solution. So why is that? Well, as we saw in the examples, if you get a 0 here, that means our 2 solutions are negative b over 2a plus 0 and minus 0. Well, if you add 0 or subtract 0, it doesn't matter. You still get the same answer. So 1 solution there. And finally, 2 complex solutions. If b squared minus 4ac is negative, that means we get the square root of a negative, and that gives us the complex solutions. Now there's one more solution or one more situation we have to keep in mind. And that is whether or not you're going to have 2 rational solutions or irrational solutions. And we saw both in the examples. Alright, so rational solutions will come about, we'll get rid of the radical if this number inside here, this discriminant, is a perfect square. If it's a perfect square, take the square root of a perfect square, we get a whole number here. And if we're adding or subtracting a whole number, that's going to give us rational solutions. But if it's not a perfect square underneath here, that means this cannot be simplified down to a whole number. The radical is going to be left in there. So we get a rational solution. So that's one more thing you need to look at. Is the discriminant greater than, equal to, or less than 0? And is it a perfect square? The only time where it's a perfect square matters is when we're trying to determine between whether or not we're getting rational or irrational solutions. Alright, so for the next one, we're going to find the discriminant and use it to predict the number and type of solutions for each equation. We're going to tell whether the equation can be used or can be solved using the zero factor property, or if we have to use the quadratic formula. Alright, now when can we use the zero factor property? Alright, we can use the zero factor property if we get 2 real solutions that are rational. or one rational solution. So long as our solutions are rational, then we can use the zero factor property to solve. All right, first example. X squared minus x minus 2 equals 0. So we get the values of a, b, and c. A is 10, b is -1, c is, c is -2. All right, discriminant. B squared, that's -1 squared, minus 4 times 10 times -2. All right, 4 times 10 times 2 is 80. That's negative. So we got 1 minus -80, which is 1 plus 80, which equals 81. So we've got a positive value. So that means we have two real solutions. And it's a perfect square. So that means the solution is going to be rational. And that means we can use the zero factor property to solve this one. So two rational solutions and zero factor property. Go to number 6. A is 3, B is -10, and C is 15. So that makes the discriminant B squared, so that's -10 squared, minus 4 times 3 times 15. All right, evaluating this, you got 100 here, minus, see, 4 times 15 is 60, times 3 is 180. So it gives us a discriminant of -80. It's negative, so we have two complex solutions. And since we don't have rational solutions, we're going to need to use the quadratic formula. Next up, part B. X squared minus x minus 7 equals 0. So A is 3, B is -1, and C is -7. All right, minus 4 times A times C. So we got D equals -1 squared is 1 minus, we got 4 times 3 is 12, times 7, that's going to be 84. And it's negative. So it gives us 85. D is 85. So it's positive, so it's two real solutions. It is not a perfect square. So that means we're going to have irrational solutions. Since the solutions are not rational, we're going to have to use the quadratic formula. Your turn, part B. X squared plus 3x minus 4 equals 0. So the discriminant, b squared, that's 3 squared, minus 4 times a times c. So 3 squared is 9, minus, it's 16, times 2 is 32, so that's -32. Sorry if you can't read that, that's supposed to be a -32. Not even close. There we go. And add those two together, we get D equals 41. So 41 is positive, so we have two rational solutions. It is not a perfect square, so that's going to give us I'm sorry, misspoke. It's positive, so we get two real solutions. It is not a perfect square, so we get irrational solutions. So two irrational solutions, and we need the quadratic formula for that one. All right, part C. You got 16x squared minus 40x plus 25. All right, A is 16, B is, that's supposed to be 40, negative 40, and C is 25. All right, discriminant. B squared, that's negative 40 squared minus 4 times A, which is 16, and C, which is 25. Negative 40 squared is 1600. Over here we got 4 times 25 is 100 times 16 is 1600. So that gives us value 0. So you got a discriminant of 0. That gives us one real solution, which is a rational number, which means we can use the quadratic formula. We can use the zero factor property to solve. All right, your turn, part C. 15x squared plus 11x minus 14 equals 0. So A is 15, B is 11, and C is negative 14. So discriminant, 11 squared, B squared, minus 4 times A, which is 15, times C, which is negative 14. So 11 squared is 121, minus negative 840. That gives us T equals 961. And 961 is a perfect square. So that means we've got a positive value, so two real solutions, and it's a perfect square, so that is going to give us two rational solutions. And it can be solved with the zero factor property. Alright. Example part D. 2x squared plus 3x plus 4 equals 0. So A is 2, B is 3, C is 4. So discriminant, we got 3 squared minus 4 times A times C. I'm sure it's up here. 4 times 16, 32. 32. There we go. Not a problem there. Okay, 9 minus 32. D is negative 23. We've got a negative discriminant. Therefore, we have two complex solutions, and we have to use the quadratic formula. All right, your turn, part D. 25x squared plus 70x plus 49 equals 0. So A is 25, B is 70, and C is 49. All right, discriminant. B squared, oops, so that's 70 squared, minus 4 times A, which is 25, times C, which is 49. All right, 70 squared, that's going to be 4,900, minus 4 times 25 times 49, well, there's 100 times 49, that's 4,900 as well. So 4,900 minus 4,900 is 0. So we have a discriminant of 0, which means we have one rational solution, and we can use the zero factor property to solve. So we've got a lot of different situations here to keep track of. As a study aid, you should make like a little table or some flashcards or something like that, and make sure you run through these different situations. All right, everybody, that wraps up Math 104, so congratulations.